Hey everyone, welcome to Tutoring. Hope you're having a great day. Today we are going to be doing a topic video on integration by trigonometric identities. So this is chapter 7E of your textbook, and it's going to use things from chapter 3 as well, because as you know, this is going to be involving circular functions, and chapter 3 is your circular function chapter. So we are going to be using the formulas you learned from chapter 3 and apply it over here in chapter 7. Right, so let's get into the topic video. Previously, you would have been able to antiderive, sine of 2x. That's fine. Sine of 2x, if you antiderive it, positive sign just becomes cos, negative cos. And then you derive the function in the inside and then divide it, and then that's pretty much your answer, right? So that's fine. We can definitely antiderive this. And I give you cos, cos negative x, the antiderive in terms of x. Well, that's fine. We get a sine negative x, and then the negative 1 comes out. And then positive cos, if you antiderive, you do get positive sign, but then that negative gives it away, that gives it the negative, okay? So that's fine. We can definitely antiderive anything to the power of 1. So when your trig functions are to the power of 1. But if I was to give you a trig function, for example, let's pick one, sine x, and then it's square, okay? So if I was to add another power, so it's not to the power of 1 anymore, it's power of 2. Or maybe if I was to antiderive cos cube instead, so this is to the power of 3. Anything to the power of bigger than 1, how would you antiderive that? Well, so I'm just going to show you the incorrect way of doing it. So some of you might be thinking, why can't we just use chain rule? So that's sine x square, antiderive in terms of x. And if we do this, then applying our polynomial's antiderivative function, well, we add the power by 1 and then bring it down. So sine x, add power by 1, that's 3, bring it down 1 over 3, and then derive the function in the inside, which gives us, or antiderive actually, cos x, but then you divide instead, and then, so if you were to use the polynomials, this is what you get, but it's incorrect. I mean, if you try deriving this, you can just check on your calculator, you would not get back into this function, okay? So that's the incorrect way of doing it, guys. You can't just use antiderive using the polynomials, the chain rule way, okay? So if that's not the case, how would you be able to antiderive sine square x then? Well, look at the title of this video. It's integration by trigonometric identities. So we're going to be using the formulas that we learned in chapter 3. So that includes your double angle formula, your your identity rules formula to help us solve for this. So to help us antiderive. So let's take a look at this question again. For this video, I'll cut it off into 3. So there's the even power function. So even power. And then there's going to be the odd power. So we have even power, we have odd power, and then we have even plus odd. So even, and then there's also going to be an odd power at the same time. Okay, so I'll go through all 3 in this topic video. Okay, so looking at even power functions, what does that mean? Well, that just means what we've just seen before. That's a sine square of x, and then antiderive that. Well, if you are faced with an antiderivative of an even power circular function, what you guys should do is use the double angle formula. So the double angle formula that we're using is the cos 2x equals to the 1 minus 2 sine square of x. Well, it depends. If you have cos square, then use the other one. So that's 2 cos square minus 1. But in this case, we have sine square, and therefore we use this formula instead. So why do we use the double angle formula? The reason why is that you can convert the sine square, so what we have here, in terms of cos 2x, which only has to the power of 1. And what have we seen before? If I give you something to the power of 1, we can definitely antiderive that. We've learned that in methods, we've learned that previously in our topic video as well, and therefore you can definitely do it as well. So if I can convert sine square into a different form so that it's antiderivable, or anti-differentiable, I don't know if that was a word, but then that's perfect, that's what we need, right? So that's what we're doing. So sine square, I'm going to make sine square the subject here, sine square of x, I'm going to bring that there, bring the cos 2x over here, so you get 1 minus cos 2x, and then everything is divided by 2, right? So another way of writing sine square is this, and then if I was to replace my sine square with this function, and you can see the magic here, guys. 1 minus cos 2x divided by 2. We're anti-deriving in terms of x. What do you get? Well, you can take the 2 out. That's fine. That's part of the anti-diff law. 1 minus cos 2x anti-derived in terms of x, and then there we go. This integrand right here definitely looks like you can anti-derive that. That's perfectly fine. What does 1 become? 1 becomes x. And what does negative cos 2x become? Well, if you anti-derive negative cos, you should get negative sine. So what we get here is negative sine 2x. You leave the function the same, but don't forget, guys, you derive the function in the inside and then you divide it. Okay, so I derive the inside, that's 2, and then you divide it, so that's half. So you bring the 2 down instead, and there we go. Put a plus c, and then you are done. So this is how you anti-derive an even power trig function. So sine square becomes this, expand it, and there you go. Okay, so that's the even power function. Now let's look into an odd power function. So I've said it before, but let's look into cos cube x dx. So we'll use sine, let's use cos instead. Okay, so with an odd power, you clearly can see that double angle formula doesn't work. Double angle formula only has sine square or cos square, right? So that's to the power of 2. This odd power is to the power of 3, and using your double angle formula wouldn't make sense. So we have to look at an alternative, and a smart way of doing that is, why not turn cos cube into cos x and cos square of x dx. Well, that's the same thing as writing cos cube, right? But I've broken it down into 1, so something to the power of 1, which is nice, that's always good, and then I've broken it into an even power function, so in this case 2. Okay, now don't fall into the trap of using double angle formula here. Yes, it is an even power function, but you only use this even power function if it's by itself. So if the even power is by itself, so you only have sine square, sine to the power of 4x, cos to the power of 2x, that's it, by itself. In this case, there's an alternative here, and what you can do, guys, it's really smart. We're going to use what we've learned so far. You convert the cos square x using our identity rule. What's another way of writing cos square x? That is 1 minus sine square x, right there, in terms of the x, okay? So, identity rule, sine square of x plus cos square of x equals to 1. Another way of writing cos square, I just move the sine square to the other side, and that's the same thing, right? So 1 minus sine square is the same as cos square. Okay, so why do we do that in the first place? Well, if you remember back to the first technique we've learned, that was simple substitution, right? So if you let u equals to sine x over here, you let u equals to sine x, you will realize that if I was to derive this du dx, I will get cos x, positive cos x, make sure we're deriving, not anti-deriving. You get cos x, and then of course dx is now du over cos x. So this is just my shortcuts. Your teacher might do a different way, so really just check with your teacher. But in this case, you can already see right here, I'm just going to rewrite this again. So just going to rewrite it over here, cos x. But instead of 1 minus sine square, I'll write 1 minus u square, because I made u equals to sine x. So it's 1 minus u square, and then I'm going to replace the dx with the du over cos 2x, cos x. And what do we see? Well, the cos x cancels out, right? So there we go. You're left with antiderivative of 1 minus u square in terms of u, and we can definitely anti-derive that, right? So that's a polynomial. You can anti-derive every polynomial here. So what does 1 become? Well, 1 just becomes u. And then what does u square become? Well, u square, you add power by 1, which gives us a 3, and then you bring it down, but when you bring the power down, you divide, okay? So it's 1 over 3 u cubed, and then always put your plus c. We're almost there. What you do next is replace the u back inside, okay? So replace it with the sine x. So it's sine x minus 1 on 3 sine cube, that's u cube, x plus c. And there we go, guys. This is how you anti-derive an odd power function, okay? So you use, first of all, you split it into an 1, the power of 1, and then you split it into the other even function. So the leftover is the even power function, but you must always split into the 1. The reason why is that 1 is going to get eliminated by your substitution, okay? And then afterwards, use your trig identity rule, sine square plus cos square equals to 1, and substitution afterwards, okay? So that is the odd power function. Now let's move on to our last one here, the even and odd power function combined together. So what does that mean? Well, here's a very simple case, I suppose. If you have a cos square of x, and then you have a sine cube of x, and then we're going to anti-derive that, okay? So if you have an even and an odd power function, This is your scenario. So what would you do instead? You've got two functions multiplied by one another. It's one is even, one is odd. Which one should we use, even or odd? Well, if this is the case, guys, odd takes priority, okay? So use the one that you do with the odd. So what do I mean by that? Well, you leave the cos square by itself. It's still cos square of x, but you do what you do with an odd power function. So odd takes priority. Don't do double angles. Do what you do with the odd power function. So you split it. So you split sine cube into sine of x, and then this into cos, not cos actually, that should be sine square of x dx, and then we can use our identity rule once again to write sine square in terms of cos square. So I'll write it here. I'll leave the sine x by itself, the loner. Okay, you always want to have one loner. Sad story of a trig function. So you always want to have the loner by itself. Now I'll just call it the fodder, and then you want to convert the other sine square into cos square. So we've done this already. Sine square is 1 minus cos square, right? And then anti-derive in terms of x. Okay, and then expand your bracket. So this is sine x right here. Cos square times 1 is cos square of x. Cos square times cos square is cos to the power 4 of x. Okay, don't be tempted to use double angle formula. We just do what we do with the odd power function. You substitute. So you let u equals to cos of x, okay? That sine x is the fodder. That's going to get eliminated. That's why we want to have one sine x by itself, okay? So u equals cos x, therefore the u, we are deriving, so you do get negative sine x, okay? Be careful, you are deriving. And of course, that would mean dx equals du over negative sine x, and you are left with, so if I was to write the integrand once again, that is sine x. I'm going to replace the u square, the cos square with the u square, and then cos 4 with the u4, and then the dx with the du over negative sine x, okay? And there we go, substitution to the rescue. Sine x cancels out again, and you are left with the antidiff of u square minus u4. And then there's a negative sign as well, so I guess you can put negative u square plus u4. And this is a polynomial. I'm sure you guys can do it, okay? So that's u cubed negative 1 on 3 plus u5, 1 on 5 plus c. Replace your whatever u was, which was cos x right here, and there we go. So it's cos cube of x plus 1 on 5 cos 5 of x plus c. And that is your final answer if you were to anti-derive this function right here. So even and odd power, okay? So that's pretty much it, guys, for this topic video. So we've learned to anti-derive trig functions when they have an even power. We've learned to anti-derive an odd power function, and we've also learned to anti-derive an even plus odd power trigonometric function, okay? So in the next video, we'll be doing a tutorial video on a much harder question than this. But aside from that, guys, thank you for watching, and I'll see you in the next video.